Hi everyone, my name is Peter Klaas, and in this tutorial I would like to show you how to create a particle wave in Houdini using subs, pops and expressions. First of all, I would like to show you the final effect, the movie final effect. So the wave is going, and you note that the height is different, so the height can be randomized. In this case there is a ring pattern going on and the forces are being applied. Note that other patterns are being possible at the same time as well. The height can be multiplied and scaled to 0. On top of that we can control the rotation, so it's a 360-degree rotation now, back to 180, rotating around the different axes, so we've got control over that as well. And then we can add in an exponential multiplier, and we can invert that exponential multiplier. And then we can scale the particles, the height, just straight back down again and just get a turning effect. So this is the same thing with a ring pattern, so note the exponential. This is the pattern we will be working with. Then this is the same thing but with a high resolution of number of geometry, and then again the same thing but with geometry chunks applied to the particles. Alright. Okay, so there's our wave, and there's it again, and this is basically what we will be working on today in this tutorial. So it all starts by selecting some points in a grid just to give that little offset over there. Then we've got a torus. The torus is going to grow and select the particles. So these are the point numbers, as you can see, being selected by the torus. So the yellow ones are the ones inside of the torus. The point numbers will become very important because we will be copying a box onto every single point and then driving those boxes. So in order to have a visual recognition of how the box's orientation is, we assign different colors to different faces of the box. Then the box is copied over the grid, onto the points, onto the particles. Texture is applied and UV texture coordinates are projected. Now this is just a bit to show the different resolutions, so different resolutions can be applied. So we can quickly prototype the effect with a low resolution, so the tiles are very big. And then we can start upping the resolution as well, so a higher amount of particles, and yet more particles over there, like this is a really high amount of particles. So, and everything can basically be controlled by a number of parameters. So we can link all those parameters together in a bunch of controls. Yeah. So you've got the grid size, the resolution, the amount of force that it jumps up, the gravity force to pull it down. You can say how much it rotates, the axis of rotation. You can keyframe all of these things pretty much, or adjust them while the particle system is running. Exponential multipliers and so on. So let's get into Houdini. Okay. So first of all, new scene in Houdini, and we will start off by making a simple grid. So I'm going to lay down a geometry operator, dive inside by pressing I, and delete the default file, and lay down a grid. Right? So there's our grid. I'm going to change it to flat wire shaded to see my wireframe. I don't need a shelf at this point. I don't need the file tab, so I'll just give myself a bit more space to work with. Okay, so first of all, what we want to do is turn on the point number so we can kind of see how the grid is going to be oriented. The grid has got several parameters such as the size and the rows and columns. We will be using this, and we could link this to, say, some attributes on a null. So generally what I tend to do whilst I'm working is lay down a null, and let's call this guy master control. And as we go, we will be adding more parameters to this which control certain elements in the system. So first of all, just to get an idea of the really basic workflow, let's lay down a copy. This is going to go into the template. Let's lay down a box. Right. And if we look at it, we've got all our boxes copied onto the grid. Right? So now what we need to do is make sure that these points of the grid, these points that drive the box information, start to move around and get information from the particle system. Okay. First of all, I'd like to talk a little bit about grouping, because we will basically group the points on the grid by bounding box of an object, by a bounding object. So I'm going to increase the rows and columns, so let's say something like 20 by 20. This will give us a fairly dense grid to work with, and I'm going to start doing some grouping operations. So let's lay down a group, so a grouping operation, and I would like to show a few problems that can occur when you're grouping. So first of all, let's lay down a sphere as well. So there's a sphere. Going to change this from primitive to polygon and hook this into the second input of the group. Note that the group is currently at primitives, and I want to change this to points, so I'm going to change this to points. Type in there $OS to refer to the operator name, so which is in this case group 1. I'm going to call this one jump group, just so that I know, okay, these are going to be the particles that need to jump. In the parameters, I'm going to disable by number, group by number, and I'm going to enable, so enable group by bounding object, right? Okay, so now you can see this is our sphere, and it's selecting exactly those points in the grid. So that's good. The problem, however, starts to happen. What if we've got more than just one sphere? What if we've got several objects? What if, for instance, let's say I lay down a transform, and a merge underneath it, and let's just select both of these guys and put their outputs in there. And I'm going to offset this guy's transform a little bit, so you can kind of start to see what the problem is. Right. So let's have a look. There we go. That's our group. Now this is all fine. Let's just increase the radius a little bit so it's a bit clearer, a bit more clear. The problem, however, starts to occur, and you can already see it, where the spheres intersect. I mean, with this kind of grouping pattern, I would like to have the intersecting points to be selected as well. But because of the algorithm that calculates if a point is inside or outside, the intersection kind of negates the effect of the grouping. So we're going to have to find a workflow around it. There are a few workflows around this. First of all, what we could do is we could convert, instead of using spheres, we could use metaballs, and they would blob together. That would be one valid solution. Or, and this is in my opinion the preferred solution, is we could use a for each loop and basically use only one primitive at a time to group, influence, say, a color attribute, and then group them finally again based upon that color attribute. Now don't worry, I will show what I mean by this. So let's start with the metaball grouping. So I'm going to lay down a metaball. It's one metaball, and I'm going to transform this one as well. So let's just say that, like that, and I'm going to merge them together. So again, like that, take the outputs, put them into the merge, and let's offset this guy a little bit, right? So what this gives us is basically a nice automated mesh, which will generate this kind of selection pattern. So from there you can kind of see what happens with the metaballs. They start to blob out. Yeah. Let's move this a little bit more. So we basically now we also have the intersection, because the mesh that is generated from this is a fairly clean mesh. Now one more thing that you should keep in mind is to polygonize those metaballs first. So you can just say meta convert, convert meta, so convert meta, right? And this will basically allow us to set our divisions or our step size. Yeah. So let's make it a bit bigger to make it rough. Yeah. And so now whatever I do, however I scale my metaballs, they will always, have this kind of resolution. Yeah. Okay, and this is the result in geometry, right? Now generally what we are aiming for is sort of a torus-like pattern. So we've got, if I lay down a torus, yeah, what I'm really looking for here is this kind of ring selection, because I don't want my particles to always be affected by the grouping. I want them basically to start scaling upwards, so the selection, the torus will start scaling upwards, and they will be affected. They will be inside of the jump group for a short period of time, and then no more. So I need this kind of torus selection. So in order to do that with the metaballs selection, what I could do, for instance, is say we've got this pattern, then what I can do is use a cookie operation, right? And just as a quick example, I'll just get this network and duplicate it, right? And I'll put this one in there and this one in there. Okay, by default we need to change some stuff. So first of all, let's lay this down a little bit better. So Shift L, select all your nodes, press Shift L. So for the cookie, we need to set this to user-defined, right? Because intersections, it's not going to give us exactly what we want, so we need to have user-defined. Also, at the moment the metaball settings are exactly the same, so what I'm going to do is scale this one in slightly. So the other one was 3 point something, so let's put this one, say, at a value of 2. Something like this. And let's have a quick look what this gives us. Yeah. And so we've got a big outer shell, and we've got the inner shell. So what we want to do is we want to, in our user-defined settings, what am I sure that I want to keep? Okay, I want to keep basically the outside of A. Yeah, so I'm definitely sure I want to keep this. So in the wireframe you can see, yeah, it's a bit of a messy geometry, but it'll work for the selection. And the other thing that I want to keep is inside. Yeah, so I want to keep the inside of B. Yeah, so the small ones that are coming in from B should go there. Now if I feed this into my grid, in my grid selection of my group, then I can see there's my sort of metaballs blobbing together, and there's my selection based upon them. So again, if I just start to move this thing around, so we could just manipulate one of the transforms over there. This value could be exactly copied onto that one. So I'm going to paste relative reference so that it's always referencing that one. Now obviously you could just use this. I mean, the idea why I'm doing this is basically because you might want to have particles trigger the kind of waves procedurally, and so you would use metaballs in that case, or other attributes which I will show. Anyway, so let's adjust this. Yeah, and now you can kind of see the grouping taking place. Yeah, so this is the kind of pattern that we're looking for, which is quite nice. Okay, but to keep it simple, in this case what I want to use is just a torus. Yeah. One of the things I want to show as well is, what if I, for instance, got my torus and my spheres? So something like, I want to have a selection out of all of these three, right? Which means I've got a torus there and I've got two spheres. Yeah. So first of all, the way to approach that is with a for each loop. So we can lay down a for each loop. Okay. The way that this guy works is it has you can jump inside. Basically it works like a block of code, but instead of a block of code it's a block of operators, so you can apply different operators inside. So the idea is that what I'm going to do is I'm going to group every single one of them, so say this torus and that one, just to show it a bit better. So let's get rid of this merge. Right, I don't need this sphere at the moment. I'm just going to be using the torus and the sphere. So the torus and the sphere. And what I want to do is I want to put them into their own groups. So an easy way of doing that is merging them together first, right? Then we add a connectivity to this. Connectivity. So connectivity is basically going to create an attribute called class, and is going to check and assign this attribute, this class, which is a number, an integer number, and going to assign, say that if all the primitives are connected to one another in the torus, it's going to give it a certain number. The primitives that are connected inside of the sphere are going to be given a different number. Okay, so we can combine this with a partition. So let's type partition, right? And now we can set the rule for the partition. The entity is primitive, so that's fine. We can just say, instead of group by color or alpha, we can use a variable, which we can find out by just saying over there, this is our attribute class, so that is that attribute is added, one point attribute class is added, and so basically we can say, for instance, select group, underscore $class. Now the reason why I do it like this with an underscore class is that we can rebuild this string, and we will rebuild this string inside of the for each loop. So let's put in this one into the first input of the for each. Okay, so let's have a look. So if I middle mouse button on this, you can see there are 100 primitives in select group underscore 0, 80 primitives in select group underscore 1. So that's quite good. What I need to have now is I want to basically start coloring the values of my grid. So let's make our grid available. Just gonna press W to switch to shaded mode. Okay, instead of grouping it this way, right, I'm just going to delete this group for now. Well, yes, I'll delete this group for now. I'm going to plug my grid into the first input, my partition into the second input of the for each loop. First of all, what I need is I'm going to basically start coloring the values. So I'm going to lay down a color and make sure that everything is colored black. So this color value over there, right, is going to be colored black. The attribute is applied to points. So note that in the beginning the grid does not have any attributes. When I attach a color to it, it has a color attribute. CD diffuse color for a point attribute. Okay. Then the for each loop itself. What needs to happen there is I need to query how much times I need to go through this loop. So I need to know how many of these primitives I've got. I mean, I've got 2 at the moment, but how do I tell the for each loop? So first of all, let's change this from each group to each number rather. So now we know that it's going to loop starting at 1, going through to 10, and this is the incremental, so by 1. So in order to make sure that my number will be correct, right, I need to have a look, right, over there, my groups, I hope you can see this, my groups start at 0 and not at 1. So I'm going to adjust this to start at 0 as well, and the final number is going to be 1. So I need to make sure that I've got something like this. The final number means it's going to use 0, and it's going to include the final number, so it's also going to include 1. Now I will be putting in an expression to make this procedural to get to the amount of primitives that we've got, but let's have a look inside of the for each loop first. Okay, right, so there's the inputs, and there is the each node. The each node is basically bringing in the previous geometry from the previous result. Okay, so what I need to have now is I need to start grouping my second input, or rather deleting. So let's delete. So you have to imagine that what is coming in here is now a sphere and a torus. So a sphere and a torus are coming in from the second input, a grid is coming in from the first input. What I want to do is start coloring those points. So first of all, I could say, let's lay down a point. Yeah. So the grid, and the grid will be coloring these guys, yeah, at some point. So that's later on. So this will, I'll name this so that I know that I've got to do this. Add color. Yeah, and you could say to selection. Right. And there we go. So the group that I need to have in there, yeah, can either be, well, it's just outside of the screen, but it can be selection group 0 or selection group 1. So in order to get the correct kind of group, I'm going to use a stamping operation, yeah, to sort of loop through my groups. Right. And I'm going to build up my string. One of the tricks that, or hints that is quite useful is inside of the each, right, there's basically the stamping function is there, so you can immediately kind of copy paste it almost, yeah, so you can get it from there if you want to, or you can type it yourself if you need to. So let's just copy this, yeah, and let's put it on delete. So at the moment the selected geometry will be delete, so I'm going to rebuild my group, right? So I know that I will be needing select grp. So this is the first part of the string, right? Right. Now I'm going to use a function, and I'll just quickly bring up the help file, just so you can find, so you know where to find it. So you bring up a text port and you type xhelp, right? And this will bring up all the possible expression functions that you can use. The one in particular that I am interested in at the moment is string cat, string concatenation. So in order to concatenate the string, right, I need to put this around this. So string cat, open braces. So this will be the first part of my string, right? So now I need the second part of my string. And the second part of my string is the number. So the number, in order to get that number, right, I've got my stamp. Yeah, my stamp will basically reference the node above. So dot dot for the parent. Yeah, and the attribute in this case that I need to use for my stamping will be the for value, right? And I could say, you know, if it's not found, then do nothing or do something, but yeah, in this case nothing is fine. Okay, so this is a function, right? I need to have this be evaluated by Houdini first before it can be used as a group. So in order to do that, put backticks around it, right? And this will basically give you the correct kind of group that you need each time it loops through the Okay, so next thing. So at the moment you can see the sphere is in there because the torus is being deleted. Yeah. So what I want to do is, instead, say I've got 5 primitives. Yeah. I want to each time select one of those and delete everything else. So at the moment, say I've got the torus selected and I want to delete everything else. I don't want to delete the torus. I want to delete non-selected. Yeah. Okay. So now all the other primitives are going to be deleted. Okay, so now I've got these guys, I've got this one, and I'm going to group the incoming points. So let's add a group to this, right? And the same thing as I did before, I'm going to group by bounding, so disable this and enable this, but instead of bounding box, bounding objects, and change it to points, right? And I'm going to give it a name, so let's call this guy selection. Group $OS, so use the name again. Okay, and now what I want to do is I want to manipulate the color information using this group. So I'm going to plug this in there, right? And I'm going to say, okay, use this selection group, yeah, to color. So I'm going to add some color to this. So I'm going to say add color. So remember, I added the color operation before and set all the values to 0. This doesn't need to be a color. This can be any attribute really, but color is an easy visualizer. It's an easy to visualize this. So +1 again, and +1 again. Right? Now at the moment it's applying this to all the points, and I really want to only apply this to my selection group. So I'm going to input my selection group, right, like this. And now my points are starting to have some color. Okay, there's one more problem though, and that has to do with the way that the for each loop works. Like I said, the way that it works is that the outgoing geometry, so say that the first time it loops through, right, the grid the first time is completely black. It comes in, yeah. A selection is being made based upon the first primitive, yeah. So the first primitive, the torus in this case, is being used. Everything else is deleted. The grouping happens by bounding object, and then on top of that the points are colored. Now the problem is this group, right, is being made, and it has a unique name. So if we middle mouse click on this little node over there, we can see 20 points in selection group. What happens is this group is maintained, is now part of the geometry, which means that the next time it comes through, right, and it loops through the loop, right, it's going to go through and it's gonna find, okay, the selection group, yeah, oh, this already exists, and you cannot make the group with this same name, so it's gonna give an error. So basically what we need to do is before we send the geometry back up, we need to make sure that this selection group over there, right, is deleted again. So what I'm going to do is I'm going to add another group operation. So add another group, and I'm not going to select anything in this case. I'm just going to the edit tab and going to delete, yeah? And the group I want to delete is selection group. So now selection group is gone, yeah? So if we look at this, so I can just call this delete selection group, so we know what's going on, yeah? And let's go back up. Okay. And now, like I said, what is going on at the moment is basically the for each loop is going through the two primitives, yeah, and is giving them color, yeah. It's going to add color to the grid. Now, obviously, in the areas where they intersect, it will become a problem, because the color values will be first time by the torus +1, so a value of 1, and then another time by the sphere +1. So really, they've got like too much, more than they need. But I told you that I wanted to make this procedural, so let's make this procedural. Again, we're going to be using some expressions, right? So in order to do that, I'm going to bring up the text port again, and the expression that I'm looking for in this case, yeah, is prim group list. So I'm just going to go there, prim group list, this guy, yeah, and I'm just going to type it out, xhelp prim group list. Alright, and let's bring up a little bit of help. So there's our subpath to that one. So what we need to do is we need to type in prim group list, and this will basically return all the primitive groups in the given sub, yeah. So what that means is if I query the partition sub, yeah, then you can see I've got one group there and another group there. So this will return selection group underscore 0 and selection group underscore 1. Okay. I'm going to combine this because this will return a string, yeah, return a string with arguments. A string with arguments, right, this can become very useful in combination with the arg command. So you've got arg over there and argc. Arg will basically allow you to choose one of the arguments fed into this function. Argc will basically allow you to count the arguments. Okay, so count the arguments. If I get a string with, 2 arguments and I can count them, then basically I've got what I need. So the way that argc works, xhelp argc, is basically you give it an input like a string, a line, yeah. So for instance, argc, this has 4 arguments, returns 4. So that's what we need, because the return value from the prim group list will be selection group 01, selection group 0 and selection group O, right? So let's combine these two and let's use that. Okay, so first of all, let's get our prim groups. Yeah? So I'm going to start typing prim group list. Yeah, I needed a sub path, so the sub that I want is my partition, so I'm gonna go up one node and start typing partition, and it's partition 1 that I need. Okay, so this will return my string, right? So I'm going to put this into my argument counter now. So basically, let's put argc around this, argc, yeah. And again, since it needs to be evaluated first, yeah, I'm going to put this in between brackets, I believe. Although, wait, no, let's have a look. It's probably, yeah, it's going to give an error because it's only when it's a string, so it's only when it's a group or something that it needs those things. If in this case it's a number that is returning, so it doesn't really need that. Okay, there is one problem, however, and the problem is it's gonna return me the number 2. Yeah, I can see it over there. If I just, this is to see the expression, this is to see the number. So it's gonna give me the number 2, and what I really want is the number 1. Yeah, because I'm going from 0 to 1 in my selection groups. Yeah. Okay, so I'm just going to say -1 onto all of this, right? And that gives me number 1. And now I've got my 2 groups, so that's what I wanted. Okay, so what I need to do now is clean up my values a little bit, so I'm just going to add a clamping operation to this by adding a point, go to add color, right? And over there, the color, I'm going to start typing clamp. This is the value it takes in, this is the value, the minimum value, and this is the maximum value. Right? So, and I need to do that for all the channels, so I can just copy this thing, go to the next channel, the green channel, put it in the green channel, and put it in the blue channel. There we go. Right? And now the values have been properly cleaned up. I suppose I could show you this in the spreadsheet. Right? So there's my color values. Some of them should start to give me some values. Maybe it's already normalized. I mean, it's a good idea to put in the clamp just to clean up your values that are coming out of it. So what we can do now is we can group by color. We can basically add a new group. There we go. And the kind of group that I want in this case is going to be, I suppose there's already a group 1 in there, which is probably not been renamed properly somewhere along the lines. Well, it doesn't really matter. Let's just name this one jump group again. Jump group, and this one $OS. You can set this by default, so you can create this, you know, you can make a default out of this one if you want to, and then, you know, that would always be the case. Okay, so I want the type that I want is I want to select points. Yeah, I want to select it by an expression, so using an expression. Yeah? And the kind of expression that I want is say $CR, so the red color value. If that color value is bigger than, let's say 0.9, then select all the points. Right? So at the moment you can see the points are being selected. Note that the points inside have not been selected. Yeah? Over there they have been selected because this is basically the sphere and this is basically the torus. Yeah? Okay, so just in order to visualize this a little bit better, let's put a little expression in there. So in the transform of the sphere, I'm just going to say $FF, so the frame value in floating point, so correct frame value. And if I play now my time slider, you can see how that kind of affects. So that's, you know, that's quite nice. That's kind of what you want for a fast, clean way of grouping your points without having to revert to metaball and metaball geometry. So, one more thing. I mean, this is all very nice and clean, and I'll leave this in, but what I'm going to do is just basically use my torus, because that will give me the correct kind of grouping pattern that I want to use for this video tutorial. So in the radius, I'm going to say, let's set this radius back to default, so you can do this by just say revert to default, so select to default, so it's quite small now. Yeah. and I'm going to start scaling him up. So I'm going to add a transform to this, and in the same way that I started, using an expression in there, I'm going to put my $FF inside of my uniform scale. This will probably be a little bit too fast. So also the problem is that at the moment this gives me uniform scaling, and what I really want is I kind of want to maintain my my radius of my torus. So instead what I can do, I can put it in there in the radius of my torus, $FF, and what this will give me is a nice scaling torus. So this causes the ring selection pattern to be, as big versus, well, okay, it's gonna be a little bit big now. That's versus this, where actually the selection is growing a lot more. So that's a better way than scaling it. So let's just delete this. Okay, let's have a look what's going on now in our jump group. So there's our jump group. There's one little problem going on. Our torus is of the type polygon, which basically means that, if I just make him a little visible, which basically means that, it's kind of chopped off, and what we kind of want is a smooth round selection, or as smooth as we can get it. So if I change this to NURBS, you get your kind of smooth round pattern. So this is, preferable. Okay. And at this point I'm going to save it. So